Welcome to our next episode of Google Earth Engine tutorial series. If you're new to this channel is dedicated for exploring different open geospatial datasets for different kind of environmental application. So in each episode, we will slightly talk about a different application. Either this is regarding the forest or hydrology or natural hazard. So today I want to show you a project on how to evaluate the Great Green Wall in China, which is also known as the Field of Shelter Forest Program. It is a afforestation program since started back in the 70s. And as this is not so much information, even there would have been some paper on how the performance of this afforestation program is. I want to show you step by step how can we do it in a hand-on with Google Earth Engine. So in order to do this, I want to share you a very nice data set from the Meta, which is the high resolution 1 meter global canopy height maps. Yeah, from my understanding, this is really with the state of the art high resolution is 1 meter resolution, and it is hosted on the awesome GE community catalog. In this dataset, the coverage is global, and you can even see individual tree level what the canopy height is like. So this will be something we play around today in the project. Apart from this dataset, we will also look into the terra climate used to maybe get a reference on the soil moisture value in the area to see before the project and after what would be the difference in the soil moisture values. And we also need to build a baseline for forest cover using the Hansen Global Forest Chain dataset. So the result will be something, that's how it look like. That will be basically like a map of the new forest area, and then we will have a little panel showing how many tree gain is actually there after the whole program, as well as some height distribution of the vegetation gain. And for this case, we are not looking into time frame all back to the 70s, but only focus on after 2000 to the current year. So yeah, let's have a look of the final result, how it look like, and we will do it step by step on Google Earth Engine together to see how we can achieve to this map. So yeah, let's go to the code. So first of all, I have uploaded the Field of Shelter shapefile, which you can also use by importing it in the feature collection. This is the path to the asset, and from there we can get the geometry of the shapefile. As this is a multiple province in China, we have to get the union of all the different provinces, and to do so we will use the dissolve function. So dissolve function will make sure the multiple polygon will be merged to one single polygon, and we are only focusing on the whole area instead of the small polygons. So there we have our geometry. To show our area, we want to visualize it in a way that is like with transparent field as well as with some boundary color. We will use the styling to make it with the red boundary and transparent field color. So yeah, then we can see the boundary clearly as well as the other layers. And we put our style layer to the map, as well as setting some option for the base map. So here is our Meta canopy height dataset. We can also do Mozart in this night, however, because we want to also make sure in case there are overlaps in the area, we could just use a median to make sure we get one single image and not an image collection, and we clip it to the project site that we have. So because we want to look into the change of soil moisture before 2000 and in the current year, actually to 2023, we are trying to build up a function here for one single year. And for that single year, we have the first day of the year and the last day. And we use the day filtering to get the soil moisture values. We will get a median for the whole year because there's also seasonal variations, and we only want to compare the annual average. And there we also need to apply like a scale factor for this soil band specifically, and to get it to our geometry. So we use this function get median soil moisture for before the time series at the time frame that we want to analyze, which is 1999, as well as 2023. We use a subtract function to get the changes of soil moisture between the two single years. We try to set up a dictionary of visualization parameters with the mean, mass, and the colors to visualize the changes. So now this is only for the soil moisture part, and to analyzing where are the new forest gain. So in order to do this, we have to first have a baseline of our forest. So I call here historical barren area, which basically means to the point of 2000, there are not so much tree cover on the pixels. So here we use Hansen dataset for the baseline reference, and we look at only tree cover of 2000 and make sure the tree cover is below 20%. And there we consider not really densely with forest, so then we can look at the difference after 2000. So here for the tree cover layer, we get the opposite. So we want the historical barren equals 0, which means the forest cover is already above 20% at that time, and we use the self-mask. So the self-mask is to mask out all areas that are equal to 0, so that when we visualize them, we don't see like all this like color that are blocking our base map. So we set it to false to make sure that it doesn't show up by default. And then we visualize our moisture change. But as we only want to look at the improvement of the soil moisture, I'm trying to use update mask to mask our area where soil moisture doesn't really improve. So I only show area with soil moisture change larger than 0, so positive change. And now we want to calculate how the trees and forests are gained. And to do that, we use the metadata set to look at in the recent year, and we have update mask for the historical barren. So we don't want to look at the canopy height where in the past there's already forest by 2000. We want to look at the new forest, and that's why we mask it with the barren area. And then we also trying to only look into trees that are higher than 2 meters. In order to exclude maybe some very small low vegetation and so on. And then we have our gain, which is in the value of the canopy height in meters, and we try to visualize them in a single layer. And as you can see in our map, in our output, apart from the map, we actually have a histogram and a little panel for showing the tree gain that we have. In order to do this, we can use some widget for this. So first of all is the histogram. We use the UI chart histogram here, and we want to visualize the new forest gain. So we are looking into our geometry, and in order to make the computation easier, we will set a scale quite a bit higher. It's like 1 kilometer here, so 1000 meters. And this is to make sure we don't get into any computation limit in the resources that we have in Google Earth Engine. So we can calculate it's more like an approximate value, so we are only calculating in the kilometers and not really focusing on super small patches. So then we have our histogram panel to put our histogram. So it's a UI panel. We need a title for our chart, so the height distribution vegetation gain after 2000, and we set some style for our label, so the chart title, and then we put our histogram there as well, and we put the whole panel in our bottom left, yeah, and we add it to our map. So we have the histogram panel down here. Apart from that, with which is the histogram panel is showing basically what the distribution of canopy height in this area for New Forest. We also want to look into the total area that is reforest after 2000 in square kilometers. So in order to do this, we also use the same gain layer. We try to count every single pixel. But here, because every single pixel is 1 kilometer times 1 kilometer, so we don't need to do any scaling here. We directly can use the value as our sum area. So we do the same with the UI panel to put this little label on our map. We have a widget which is called a UI label. So we have our title, the field of shelter bell with tree gain, with our style, and then little cute emoji. And for the sum area, we have to get our property, which is the cover code. By inspecting what the sum area look like, we know that okay, the cover code is what it is stored our information on tree gain. We have to use get info in order to actually get the computed object into value that we can show on the map. And we put our unit there, we set up the position of the label we want to put, and we also put this panel to the map. At the end, I'm just looking into a very specific area so we can see nicer result. So yeah, here it is. We can have a look how it look like. So basically, we will see we have around over 200,000 kilometers of tree gain after 2000. Okay, that's quite a lot, but we also have to consider this is a huge area we are looking into, basically a large part of North China and below the Gobi Desert. So we can see a lot of tree gains here, for example, in this area. We can also look into a more big picture of the whole area. Perhaps that would be interesting. So now we are not seeing the polygon yet because that's how massive the area is actually. So we are trying to zoom out and see our whole study region. So however, even there's a huge area of being reforest, we also, when we look at the height distribution, we see that actually most of the reforest area have rather quite low canopy height. So you see for canopy height above 10 meters is already super little, and most of the tree gain, they are actually way below 10 meters or even maybe just 3 meters, 4 meters. It might achieve the function of avoiding the Gobi Desert expanding, but it might not be actually a lot of carbon stored there, which might be also something interesting. If you want to find out, you could also try to plot a histogram of the forest carbon and to see how it is in this area in China. So yeah, I mean, you could also play around yourself and to understand better how the project is like, what's the performance, where are the areas that are mostly get with forests. For example, this area is next to Beijing, and we could see, oh, by the way, actually we do not only have this layer of canopy height, we do also have, can we look into the forest tree cover in 2000. So if we zoom in, let's zoom in here, then we can see the basically new forest area are always forests in a way that are close to the original existing forest, so to say. So we can compare the differences. And also we can look at the soil moisture change. And we are only looking into positive change here. So if we zoom out, then we can see in the soil moisture change layer, they have relatively not very high resolution. However, we can also see some kind of like patterns where in the south of the desert, we can see some improvement in the annual soil moisture average valued in this part of China where the project is implemented. So you could also feel free to play around yourself, and that's it for today. Thank you very much.